Wiggle your fingers, wiggle your toes, bend your knees and your elbows, and look and see if everybody is doing it too, just like you. Stop bobbing up and down with your arms to the side, then flap them up and down like a butterfly, and look and see if everybody is doing it too, just like you. And if we all do the same, we'll all be together, moving around as one. And if we all do it now, we'll all be together, having a whole lot of fun, just like you.
Hello, and welcome to the Barnes Children's Literature Festival at Home. My name is Demet, and I'm from Berlin, but I've been living in England and volunteering at the festival since 2016. Science is a fascinating subject and something we should all know more about. So settle in and buckle up as Dr. Mandy Hartley takes us on a journey to learn how DNA works and tells us all about the real-life inspiration behind her book.
Hello and welcome. Today we have the most fantastic video for you, and it is all about my book, The DNA Detectives to Catch a Thief. So today we're going to read a little bit from the book, and it's going to be acted out by some fantastic actors who I'll introduce you to later. We're also going to collect some clues and find out how the forensic scientists will get DNA from these clues, and then we're going to extract some real DNA. So a little bit about me. My name is Dr. Mandy Hartley, and I have a PhD in genetics. And I wonder how many of you out there like fish fingers. Put your hands up if you like fish fingers. Well, I have used DNA to make sure there's enough fish in the North Sea for your fish fingers. You are very welcome. I've used DNA to help people with genetic diseases, to find out what's wrong with them and help with their treatment. I've used DNA to reunite long-lost families. I've used DNA to solve high-profile criminal cases, and I even set up the forensic laboratories now used by the Norfolk Police. So I thought I'd tell you a little bit why I wrote the books. Because now what I do is I go out to schools and I run workshops and I teach children as young as 4 years old about DNA. And I tell stories to teach children about complicated things in science like evolution and natural selection. So imagine if I could put that into a book. So when I was young, I always loved science, and I've done some really, really interesting things. So if I could write that into a book and get children as excited about DNA and science as I am, it would be fantastic, and maybe I could inspire the next generation of scientists. And also, I'm a mum, and I have 2 amazing children, and they do really, really funny things. And I thought, wouldn't it be great if I could record some of these things in the book, within the story? And then in generations to come, Annabelle and Harry could say to their children, my mummy wrote a book about us, and we could remember the funny things they did. For example, imagine the other day I went into the lounge and there was a funny smell. And as I got nearer to the telly, the smell got stronger. And in fact, when I looked behind the telly, the smell was revealed, because there in front of me were 12 very mouldy and decayed apples. Now what Harry had been doing is, instead of going to the kitchen to throw the apple cores away, which isn't far away, he just got them and lobbed them behind the telly. Now I imagine if I was your mum and I came and said, look, what have you done? There's all these apple cores behind the telly. You would look ashamed and you would be appalled by your behaviour. Do you know what Harry did? He laughed and laughed and laughed. He thought it was the funniest thing ever. So that story is in one of my books somewhere. So I thought maybe now's the time to introduce the actors for the show to you. So we are really lucky today, because today the part of Annabelle will be played by the real Annabelle, and the part of Harry will be played by the real Harry. Oh. And even better, the part of Millie will be played by the real Millie. So without further ado, on with the story of the DNA detectives to catch a thief.
Getting dark as the family sat down to eat. Sausages, beans and chips. Everyone's favourite, apart from Harry, who preferred peas. But it was very much Millie's favourite. Strangely, uninterested in her food, Millie scratched at the back door to be let out. "What's wrong with her today?" asked Harry. "She growled at Mr. Baker too," added Annabelle. "She was probably surprised when he popped up over the fence," said Dad, getting up to let her out. "And you know what she's like. She's convinced it's her job to defend the house." They carried on eating as Millie barked outside. When they'd finished their chocolate pudding and ice cream, Mum opened the back door and called, "Millie!" Annabelle sat expectantly, waiting for their little dog to come bounding in, eager for leftovers from Annabelle to be slipped to her under the table. But she didn't come. Dad frowned and got up to join his wife. They went outside, calling Millie's name. Annabelle and Harry could hear their parents' shouts, but no barking in return. They looked at each other with a sense of unspoken panic. Eventually, they put on their shoes and coats and went outside. They found Mum and Dad standing looking at the garden gate. It was swinging open. Millie was gone. "Now do you believe me?" raged Annabelle. Mum said nothing. "Believe what?" said Harry. "There's a pet thief on Chapel Terrace," said Annabelle. "And they've taken Millie." The next morning it was cold outside, but the sun shone brightly into the kitchen at Chapel Terrace. Maybe the sun was trying to lift the very grey and sad mood that gripped the house. Breakfast in the Wallace household was unusually quiet until Annabelle broke the silence. "I couldn't sleep last night," said Annabelle. She looked pale and tired. The worry showed on her small face. "I kept thinking about Millie and that she was all alone. I think she'll be missing us." "Me too," whispered Harry, softly. As he said it, he looked out into the garden, his head full of thoughts of Millie. "I think she'll be missing me most of all." Annabelle would usually have argued back. She would have told Harry in no uncertain terms that Millie would not be missing him the most. She stopped herself, looking at her brother's face and catching his beautiful green eyes, normally so sparkly with fun. This morning they looked so sad. They were red and puffy, just like hers. She knew exactly how he was feeling, and, for once, she wanted to protect him. "I really miss her, Mum," he said, pushing away his cereal bowl full of Cocoa Pops. On a normal morning, he would be tipping the bowl into his mouth when Mum wasn't looking to drink the last scraps of milk. Today, it had hardly been touched. There was a chance that Millie had simply run out of the gate and got lost. But there was also the horrible possibility that Millie was the latest victim of the pet thief. "Come on, Annabelle, let's go outside," said Harry. He didn't like the doom and gloom that was filling the kitchen. It made him feel trapped, like he couldn't breathe. He didn't want to tell anyone that he had cried into his pillow last night. He was trying to show everyone how brave he was. Maybe beating Annabelle at a game of football outside was what he needed. "Come on." Harry, being his usual lazy self, waited for Annabelle to retrieve the ball from the flower bed for him. But as she went to pick up the ball, she gasped, "Harry, come quickly!" Harry, startled by the urgency in her voice, ran over. They both stared at the large footprint deeply embedded into the soil by the fence.
"Quickly, Harry, this is a job for the DNA detectives. Let's get changed in 3, 2, 1. Come on, Harry, let's go."
And I think there could be more clues out there. But we need to work out how to get DNA from these clues, because it's the DNA that we need to catch our thief. So we need to find out what DNA is, what cells are, and what kind of things we can get DNA from. Now I'm going to need some equipment to help me, so let's see if we can do some more magic. Are we ready? Ta-da! And excellent. Now I have all the equipment I need to tell you about DNA. So we need to start off by finding out what DNA stands for. So it stands for deoxyribonucleic acid. That's a bit of a mouthful, isn't it? Let's just call it DNA. Now earlier, I went into Harry's room and I stole his favourite Lego. It's a helicopter. But I wonder if you can work out what we could use in this box that would help us build this fantastic helicopter. What could I use that would help me build it? That's right, the instructions. And did you know that you are just like a box of Lego? You need instructions to build you as well. And those are instructions are your DNA. So let's think about what things are in your instructions. Your eyes, your eye colour, your hair, your head, every single part of your body. In fact, stick your tongue out at me. Who can roll their tongue? I can't. My instructions say Mandy cannot roll her tongue and she will be very jealous of people that can. Do you like Brussels sprouts? Hands up if you like Brussels sprouts. That's also in your instructions. The scientists have found a bit of your instructions that decides whether you like Brussels sprouts or not. Now your DNA needs to be kept safe, because if it got battered and bashed about, you might end up with 10 heads and 5 legs, which is great for Halloween, but not the rest of the year. So your DNA needs to be kept safe in a special bag called a cell. Now around the outside is a membrane called the cell membrane, and that lets things in, but also lets a few things out as well. And then inside is a jelly-like substance called cytoplasm, and right in the very middle is the nucleus. Can you say nucleus? And that is where the DNA is. Let me show you a picture of what our cell looks like. And here we can see the membrane around the outside and the nucleus in the middle with the DNA inside. And that's brilliant, you're thinking. I now know that DNA are the instructions and it's kept in this very special bag called a cell. But where is it? Well, it's all round our bodies. We have cells everywhere on the inside and outside of our bodies. And all those cells have a nucleus with DNA. But there's one cell that doesn't have a nucleus. That's the red blood cell, because it's too busy carrying oxygen. So we know that these cells are all around our body. But I wonder how many cells you think are in our bodies. Have a guess. More than 10, my friend. 1,000? More than that. 1,000,000? Oh, much more than that. 1 billion? In fact, it's 37 trillion. 37 trillion cells of your entire bodies. Now imagine if I said to you, you need to sit there for 37 trillion seconds. Do you know how long you'd be sitting there? You'd be sitting there for 1,167,202 years. That is a long, long time. But that's how many cells are in your body. So we now know that DNA are the instructions to build us. We know that our DNA is kept safe in a little bag called a cell, and the DNA is in the nucleus. And we know that there's 37 trillion cells in our body. But how big are they? Are they as big as a raisin? Some of you said yes. Some of you have said no. Okay, how about a granule of coffee? Are cells and DNA as big as a granule of coffee? No. Some of you have said yes. Oh, no. Okay. What about a little crystal of sugar? Well, some people have put their hands up. Some people still aren't sure. Some people think that cells and DNA might be even smaller. What about a tiny grain of sand? Sorry, did you say smaller? You are spot on. They're in fact so small that we need a microscope in order to see them. And in fact, this is what some of these cells look like under the microscope. You can see they're all different sizes and shapes depending where they are in the body. I personally like the brain cell because it's very long and stringy. But they all have, you can see the green spots in each of these, and that's the nucleus, and that's where the DNA is. So now we're experts. We know all about cells. And in fact, if you imagine them being tiny, this might be a section of your skin. We can see it's made up of lots of these tiny cells, and match them all with a little nucleus inside, and the cytoplasm. And this is on a bigger scale. This is just a model. As you know, we'd need a microscope to see it. But this makes up our layers of skin and the layers around our tissues, and makes up our organs. So now we need to be forensic scientists. And forensic scientists use a phrase that is, every contact leaves a trace. So if I go to a crime scene, I'm going to leave a bit of me behind there. I might leave some of my skin cells. I might leave a hair. Maybe a hair would fall out. I might sneeze. Achoo! And that would cover the table. Maybe I might pick a bogey and wipe it on the table. It depends how I feel. But I also may take something away with me. Maybe a fibre, maybe a bit of wood. Maybe I've got a splinter in my skin, so I would take something away from the crime scene. So let's think about those clues that Annabelle and Harry are going to find, and whether they would have any DNA on them. Let's have a look in my magic black box. So this first one here, a yellow liquid that a human produces. Yes, you're right, no giggling, it's wee-wee. Maybe the pet thief might have weed in the garden, and if we found some of the wee, we could get DNA from it. A cup. Every contact leaves a trace. Every single thing that you touch, you will leave some of your cells behind, and they are full of DNA. So when I drink from this cup, I'm leaving DNA from my lips here, and cells from my fingers here. So maybe if the thief leaves any objects, they will be covered in their cells and their DNA. Ooh, like these socks here, Harry's stinky socks. Think about what you wear. Everywhere where your clothes rub against your skin, DNA will be left behind. So if I think about this top where it rubs against me, around the cuffs inside would have lots of DNA. Around the collar, and also if you think about your socks, maybe if you wear sandals, sunglasses, earrings, anywhere where your clothing, things that you wear rub against you, like bracelets. These are fantastic bracelets for getting DNA because they trap your skin in them, so you'll have skin cells in between them. So anywhere where your clothes rub against you will be full of DNA. So here we have a clear liquid. What could this be in your body? That's right, it's saliva. So you saw me sneezing earlier, and as we know with corona, it spreads droplets, all full of cells from your mouth and nose, full of DNA. So maybe there might be some saliva in the garden. Here, hopefully you can see in the bottom there something that all children like to chew. Yes, that's right, nails, full of DNA. Imagine if you scratched somebody, their DNA would be underneath your nails, and we could prove then that you'd scratched them. Let's see what else we've got in here. Ooh, something brown and lumpy. What could that be? Stop giggling. That's right, it's poo, a fantastic source of DNA. Maybe the pet thief had a little poo in the garden. We'll have to look out for that. It will be full of DNA. If they have. Ooh, a tissue with something green on it. All children like to eat them and pick them. That's right, bogies, a fantastic source of DNA. And as a forensic scientist, you'd be thrilled if you found a tissue with bogies. So keep your eyes open. Maybe there might be some bogies in the garden from the thief. I've got a few more. So this one is full of hair. And hair is really interesting because we're only interested in one bit of the hair. And that's the white bulb that you've probably seen on your hairs if you look at your hairbrush. That's the root. And the root is where the cells are. And you will only get DNA if you have hair roots in your sample. If you just cut your DNA, if you just cut your hair, you wouldn't get any DNA because there's no root unless you have lots of dandruff. So hopefully if we find any hair from the suspect, it will be full of roots. Last one. Oh, fantastic. fantastic, a lovely red substance. You're right, that's blood. Oh, hold on. Yes, you're right. I did tell you that red blood cells didn't have any DNA in them because they didn't have a nucleus. But we're interested in the white blood cells. So what the forensic scientists would do is they would spin these down and collect the white blood cells and get DNA from the blood cells. Now maybe the pet thief has caught themselves maybe on the fence full of DNA. So, back to the garden. Keep your eyes peeled for any of these kinds of materials that will be full of DNA. That hopefully we can get some DNA from that pet thief. Go for it, DNA detectives.
Next to it was a cigarette. Just above the footprint on the fence was a clump of black curly fur, and more worryingly a red stain that looked like blood. Do you think it might be Millie's blood? Stammered Harry. Thinking the worst but wanting to reassure her frightened little brother, Annabelle said, "No, I think it's more likely that if someone did come into our garden to take Millie, they could have cut themselves on the fence." Annabelle stood up straight and looked around her. "There may be other clues," she said. "Let's search the garden." Harry ran off and shortly shouted over to Annabelle, "Look, a hat and a glove! Right here, Annabelle! They were just lying on the grass." Annabelle ran over and could see there was a navy blue baseball cap lying upside down on the damp grass, and a large glove. "Harry, what are you doing?" asked Annabelle. She looked over in amusement at Harry. He was straddled over the hat with his legs on one side and arms propping him up on the other. His face was close up to the hat. "I wanted to see if there were any hairs in the hat," he answered, "but I didn't want to get my trousers wet by kneeling on the grass because Mum would get cross." "Why are you looking for hairs?" said Annabelle. "It might be a clue to who took Millie," said Harry excitedly. Both children smiled at each other.
Back, everybody. What's that? Annabelle and Harry found lots of clues in the garden. How many do you think they'll be able to get DNA from? Fantastic. Well, we're ready to start work on them. Hold on a minute. It can't be like this. I'm going to contaminate all the samples with my DNA. I need to get dressed into the proper outfit. See you in a minute. Bye. Ta-da! And now I'm dressed, ready to analyse the samples. If only I had a clone to help me. Fantastic. Look at that. Thank you, clone. That's a look at all these samples that Annabelle and Harry have collected. I'm just going to move this down so that you can actually hear me. But I would have to wear all this equipment and I would have to try not to touch my face, just like with coronavirus. And actually in the laboratory we would only process one sample at a time. So this is the first sample. Do you remember it was the blood on the that they collected from the fence? So the first thing the forensic scientists would do is test it with a special chemical that would tell whether it's blood or not. So we're going to try and extract DNA from it. So we'll put it into the tube. Everything will be cleaned, even the racks and the tubes, and be exposed to UV light to kill any DNA so they wouldn't be contaminated. And that's our first sample. Now in a real forensic laboratory, the tubes would be a lot smaller. They would be this big and they'd have lids on them to stop contamination. So that's our first sample, and as we know, blood is a really good source of DNA. So let's hope we get lots of DNA from that sample. Now also, on the fence, we got this bit of fur. Who can remember which bit of the hair we're likely to get DNA from? That's right, the root. So we probably wouldn't use all of this hair, but we'd have a look, see if we can find a little bit of it that has a root on it. And then we'll put a small sample into the tube. And again, we wouldn't really process all the samples together because we wouldn't want to contaminate them. They'd all be processed individually. So we've got some lovely hairs with roots on there, and in between, we'll clean the tweezers with a special chemical that would kill any DNA. So next, we have the cigarette. Now, can you remember, if somebody is smoking a cigarette, they'd have lots of saliva, and they would have covered the end of the cigarette in saliva. So that would be a really good source of DNA. And what the forensic scientist would do is they would take a DNA swab, which we have some over there. If I could just ask my assistant. There's some swabs just there in the bag. Fantastic to pass over. The first thing we do is take a swab and run a swab all the way over it. Here we go, fantastic. So these would all be sterile and clean. Hopefully there'll be lots of cells on there. So again, we'll put that one into here. And then we'd probably cut a little bit of material from the end of the cigarette as well and try and get DNA, or even from the filter that's inside the cigarette, and try and get DNA from that as well. So we're cleaning our equipment as we go along. So the next thing that Annabelle and Harry found was the glove. So do you remember, every contact leaves a trace, and clothes, where they rub against our skin, will have traces of cells and DNA. So these gloves would have rubbed against the skin of the thief. So just in here, there'd be lots of skin cells. And with the real forensic scientists, you would have special forensic scientists that do the collection. So they take the DNA off with swabs and cut bits out, ready to be processed in the lab. So that would be two separate processes. Obviously, we're just doing this here. So let's put this one into here. So hopefully lots of skin cells in there. So we should get some DNA from that glove. And then let's have a look. Do you remember the hat? Do you remember that Harry leant across it to see if he could see if there were any hairs in there? Well, let's have a look ourselves and see if we can spot any hairs. Lots of hairs in there, and I can see there's some wonderful roots. So I think we should get lots of DNA from that sample. So let's get those hairs into the tube. That's a really, really good source of DNA. And what we'd probably do in the lab is we'd save a little bit of the hairs behind, just in case this first sample didn't work. So now, just think with this cap, where the cells and the DNA are going to be. Have you ever worn a cap and gone like this? You're rubbing all the cells off. So that's right, so the hairs would be inside the rim, especially here. And some of those cells would have gone underneath as well. And hopefully it's just the suspect, the pet thief, that's worn this cap, because otherwise we'll get DNA from lots of people. So let's cut that one off into the tube. And we're now ready to go into the DNA extraction lab. Now we've collected our DNA evidence. Let's hope we get some DNA so we can catch whoever is the owner of the glove, the hat, and the cigarette, and the blood. On to the next. Hello everybody, and welcome to the DNA extraction laboratory. I've just been given these samples, forensic samples, to extract DNA, so we're going to give you an example. So, because it's not really a forensic laboratory, I can take off my mask and my hood, but I definitely still need my safety glasses because I'm working with chemicals. Now, we collected these samples, but I'm going to show you a DNA extraction with a banana. And the technique, although the chemicals might be slightly different, and in a real forensic laboratory, remember the tubes would be a lot smaller, the actual what's happening would be the same. You can try this at home. So all living things have DNA, so this banana has DNA, and actually we share 60% of our DNA with a banana, but you could maybe do a kiwi fruit or a strawberry. So the first thing I'm going to do is peel my banana, and I'm going to chop it into really small pieces. There we go. And then I'm going to put them into this bag. Also, this is like the sample being in the tube. So just like with our samples, we now need to mush up our DNA. So I'm going to squash the banana in the bag. And you need to make sure that every single little banana is squashed. And don't do this, because sometimes the bag slips and you'll get banana all over your face. So here we go. I've nearly got all the bits now. So a good 5 or 10 minutes squishing your banana. Can you see it's lovely and smooth? So now I need to make what's called a DNA extraction buffer. And we would do the same with this sample. We would add the DNA extraction buffer to our sample. So the first thing we're going to add is some salt. So I'm going to add this into my water. The water is warm because we need the salt to dissolve. And the same thing would happen with our samples. We would add a DNA extraction buffer which contains a salt. And I'm going to explain to you what the salt does in a little bit. So we need all the salt to dissolve. So you can see it hasn't quite dissolved yet. So this might take a while. So I'm going to need my magic wand. Excellent. So now you can see the liquid is lovely and clear. So now we're going to add some soap, some detergent. And again, the buffer that we would use with these samples also has a detergent or a soap in it. Okay, let's give that a really good mix. We want to try not to get too many bubbles. You can see it's a lovely gloopy solution. And now we're going to add that to our banana mixture. Make sure your bag is sealed. And make sure you squeeze the air out. And then this takes quite a while. You need to mush it around for a good 10 minutes. So I think I'm going to need my wand again. And it's finished. All those lovely bits are all mashed up. Now we need to do something called filtering. And if you're having a go at this at home, you could use a jug or a tea strainer. And for the filter, you could use a J-cloth or a bit of paper towel or even a coffee filter. So let's get my tube ready. I'm going to use one of these tubes. And here's my funnel. I'm going to very carefully pour my banana into the filter. Now you've got to be really careful if you're using filter paper that you don't go over the top of the filter, because otherwise it won't filter properly and all the banana will come straight through. So this takes quite a while and we've got to be patient, but I've got something that I can show you while we're waiting. Now in our forensic samples we would do something similar at this stage. So we would have added an enzyme which helps break down the cells, and we would also filter, but we would use a filter which is in a tube, so it's a very, very, very tiny filter. So we can see our samples coming through beautifully. You can remember the first thing that I did. That's right, I chopped up the banana and put it in the bag and I mashed it up. And even just mashing up some of that banana would have broken open a few of the cells. So I want you to imagine these are our banana cells. So some of them would have broken open, but we want all the banana cells to break open because we want lots and lots of DNA. So we made something up, a buffer. Can you remember what it was called? That's right, a DNA extraction buffer. And who can remember what was the first thing we added? We added some salt, didn't we? Put some salt in. And the salt is going to make our DNA at the end clump together. So we added our salt, and then what did we add? Can you remember? That's right, we added some soap, some washing up liquid. Now the soap is really important. It has a really important job because when we add it to our cells, our banana cells, it dissolves all the membranes. Do you remember those membranes around the cell? It dissolves them, so all the cells break down, even that membrane in the nucleus. Can you see our DNA here? So even that membrane around the nucleus breaks down. And what we end up with is all these bits of cell, and our DNA dissolves in that DNA extraction buffer. So we can see at the moment that we've got all the broken down cells in here, and the DNA dissolved in that DNA extraction buffer is coming through without all those broken up cells, and it's doing a fantastic job. It looks wonderful. So now we need to get rid.
Enzymes.
Now we need to get rid of all the cell bits. So we need to filter it. And here is my filter. So let's filter this solution and get rid of all that cell debris. Wish me luck. Here we go. Fantastic. So, all the membranes broke down, and in here we've got dissolved DNA, just like we've got dissolved DNA in here, but we can't see it. We need a way of precipitating it, getting it to come out of solution so we can see it. So in a minute we're going to add some alcohol. So I have some alcohol here, and I'm going to add it to this solution. Now this for me is the most magical moment ever, and when I saw this for the first time at university, I had a light bulb moment, and it was the thing that made me decide I wanted to work with DNA, because I realised if I work with DNA I could work anywhere in the world on any animal. You think of your favourite animal. Somewhere in the world somebody will be working extracting DNA from that animal to help conserve it or help it with diseases. So I could work on any animal if I wanted. If I got bored of animals, I could work on humans, because the techniques to extract DNA and work with DNA are exactly the same. So here we go, guys. I'm going to add the alcohol, and what you'll see is like white cotton, and that is DNA. That's the instructions to build a banana. So here we go. Are we ready? Here we go, the alcohol going in. And in a minute, when we do the same with our sample, you will see the DNA. So magically, the DNA should appear. So I want you all to look over to that corner there. Look behind you. Look behind you. And when you look back, look at that. The DNA has magically appeared. I think it's time to see some banana DNA. Are you ready? Let's do it. So are you ready to meet some DNA? Maybe this will be your wow moment, and you might decide, like me, that you're going to work with DNA. Very exciting moment. So here we have our filtered DNA. So it's all in solution at the moment. And we're going to add the alcohol to make it come out. So you definitely need your safety glasses, and get a parent to help you with this. So I have got some surgical spirit, but you could use vodka, or you could use rubbing alcohol, and you need to put it in the freezer beforehand, so it needs to be really icy cold. And then you need to just dribble it down. So get ready to see those white strands of DNA. Here we go. Can you see them? Wow, we've got absolutely lots and lots and lots of DNA there. Banana DNA right in front of you. So right there are the instructions to build a banana. And remember, we share 60% of our DNA with a banana. So we might even be able to pick some up. Look at that. Amazing. Well, what an exciting day we've had today. We have collected DNA from our samples, we've learned what DNA is and cells, and we've learned how forensic scientists collect evidence to get DNA. We've extracted a fantastic amount of DNA from our bananas, and we've had a brilliant storytelling session acted out by the very own Annabelle, Harry and Millie from the book. So if you would like to find out more, and there's some more exciting activities, you can go to my website, which is www.thegeneticist.com. thelittlestorytellingcompany.co.uk, and there's some fantastic web links there. And if you did want a signed copy of my book, you can get one from there, and I can send it out to you. So lots of love. I hope you're enjoying